Alright, y'all. Unit 2, Day 1. We're going to be discovering the parent functions, okay? There are, there's 6 that we have on here, but the parent functions are not just limited to this. The parent function is just the generic, basic form of specific functions. You got your linear, your sine, your cosine, your quadratic, your absolute value. Basically, any kind of an operator that involves functions, there's going to be some kind of a parent function that revolves around it. So, today we're going to be talking about what those look like and how those work. Okay? So, the first one that we have up here is going to be our absolute value function. And this one is going to start at the origin, okay? And it's going to go up and to the right with a slope of 1. Okay? And all the parent functions look like this, okay? For absolute value. Or, well, let me rephrase that. This is the parent function for absolute values, and all the absolute value functions will kind of sort of look like this in some way, shape, or form. They're going to have this really sharp turn in the middle of it. That 90-degree bounce, okay? And that 90-degree change might vary a little bit, okay? But you're always going to have that like bounce back in the middle, okay? And then, let's see, our domain for this one is going to be negative infinity, less than x, less than infinity. Okay? And the range, if you'll notice, the range actually stops right here. Okay, it doesn't go any lower than that blue line that I just drew. So, what that means is 0 is our lowest part, and then, let's see, we're going to go less than or equal to, because it does actually hit 0, y less than infinity. The root for this one is going to be x equals 0, and the y-intercept is going to be y equals 0. This one is symmetric with respect to, and you'll see me use this abbreviation quite a few times. Respect to the y-axis. So this one starts down here at 0, 0, and it's 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, and negative 3, 3. And there it is. Okay? Very simple, okay? It's the most basic of absolute value functions. Okay? The quadratic function. Okay? Now, as we all know, the quadratic function starts in the middle and does this little number. And let's see, we've got points at negative 3, 9, negative 2, 4, 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Okay? And then we've got to go ahead and write down our points. 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. Okay, and as you notice with this one, just like the absolute value function, it bottoms out right here, okay? That is also what's called a minimum, okay? Now, the domain for this is going to be negative infinity to infinity, okay? The range is negative infinity, less than y. Oh, nope. The range stops at 0. Oopsie. That almost was bad. Okay. Our range starts down at 0. Okay. And since y can actually equal 0, we have the less than or equal to, and then y less than infinity. Alright? And then our roots for this one, well, there is only one root, and that's going to be x equals 0. The y-intercept is y equal 0. And the symmetry for this one is with respect to the y-axis. And there it is. So now we're going to go on to the next thing. Okay? So let's see. Okay, let's see. On number 3, we got the square root function. And if y'all remember correctly, the square root function basically is half of the inverse of the quadratic. Okay? Now this one's going to start at the origin again, and that's going to be 1, 1, 4, 2, and 9, 3. Okay? And it's going to kind of arc up into, the right. Like that. So we're going to start off at 0, 0. And then we're going to go 1, 1, 2, 4, 2. And 9, 3. Okay? Negative 1 is going to be undefined. Okay? Now the domain for this one is going to be negative infinity. Or rather, the domain for this one is going to start at 0. And since it does actually hit 0, we're going to do it like that. Okay? Now another way that we could do this is say 0 with a bracket on it. Oops, not a y. I need an infinity. Like that. And then the roots for this, that's going to be x equal 0. The y-intercept is y equals 0. And the symmetry is non-existent. Okay? And let's see. Next thing we got is our cubic function. Okay? Cubic function is a rather interesting function, okay? Let's see, we're going to have 0, 0. And that's going to be 1, 1, 2, 8, and 3, 27. Negative 1, negative 1, negative 2, negative 8, negative 3, negative 27. Alright? And let's see if we can graph that. So negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, 2, 8, and there it is. And we connect the dots. Goes like that. Alright, and our domain for this one's going to be negative infinity to infinity. The range is going to be negative infinity less than y less than infinity. The roots are going to, well, there's only one root, and it's going to be x equals 0. The y-intercept for this, of course, is y equals 0. And this one has a unique symmetry. If you'll notice, if we fold it across the y-axis or across the x-axis, it doesn't work. It doesn't do anything for us. But if we fold it across the y-axis and the x-axis, it's all of a sudden symmetric. Okay? And we call that symmetric about the origin. Alright? Alright, last two problems. So we've got our cube root function now. Alright, and this one is going to, again, start at the origin and go 1, 1. And then we're going to go over to 8 up 2. And then we would have gone all the way out to 27 and up 3, but we don't have the space for that. Okay, and then right there. And now we can take this and draw ourselves a little line that goes like that. Oops, missed the last part of that by a long shot. Let's see if I can do that. There we go. Okay, and it kind of goes like that. Okay, now as we can see, the domain for this is going to be negative infinity to infinity. Okay, the range is negative infinity less than y less than infinity. The root rather is x equals 0, and the y-intercept is y equals 0. Again, the symmetry for this is about the origin. Okay. Come on. There we go. About the origin. Alright. And the points, the crucial points for this, 0, 0, 1, 1, 2, 8, and 3, 27. Alright, and then we got negative 1, negative 1, negative 2, negative 8, negative 3, and negative 27. And there it is. Alright, last one. We got our rational function. Okay? And on this one, we're going to, if we tried to start at the origin, okay, we'd wind up with a point that's actually undefined, okay? Now, we are going to have 1, 1, 2 and 1/2, and 3 and 1/3. We have negative 1, negative 1, negative 1, negative 1/2, and negative, or not negative 1, negative 1/2, negative 2, negative 1/2, my fault. Negative 3 and negative 1/3. I'm trying to talk too fast. Okay? And that looks it's going to look a little odd at first, but that's okay. Okay? So, negative 2 1/2, negative 3, negative 1/3. And it kind of goes a little something like that. And the other curve goes like that. And it's going to sweep in close to the origin. I mean, it's going to get close to the origin, and then it's going to swing out the other way and get close to the x-axis. Now, it's never going to actually touch the x-axis, and that's what's called an asymptote. And we will discuss that in depth this semester. So, and they're really cool. Now, our domain goes from negative infinity to infinity. Okay? Union. Or not negative infinity to infinity. What am I thinking? Sorry. Just sneezed. Okay. So negative infinity to 0. And then it picks up and then it goes and shoots all the way up there. So from there, it's going to go to 0. And then carry on out to infinity. And there it is. Now our range for this is going to be the exact same thing. It's going to be negative infinity to 0. Union 0 to infinity. And there it is. Now our roots for this, well, since it never actually touches the x-axis, it's going to be non-applicable. the y-intercept for this is going to be the exact same thing, non-applicable, since it doesn't actually touch. Okay, now there are going to be occasions where we're going to move these around and it will wind up touching and stuff's going to happen, and it's really interesting and neat and cool. Okay, our symmetry for this is going to be the origin. Because if you notice, we can flip it over this way and then flip it around that way, and we'd have the exact same thing. Okay, and there we have it. Thank you for watching.